In this video, we're going to cover section 2.2, testing for validity using the true-false method, which is a direct approach. In the previous lecture, section 2.1, we were still testing an argument for validity, but we were using the truth table method. So we were actually creating the entire truth table, and we were looking for the instances where all premises were true, and then we wanted to see if the conclusion was true as well. And if all instances, had a true conclusion, we could say the argument was valid. Otherwise, if true premises lead to false conclusions, those would be the examples, that would make the argument invalid. There's a more direct approach to doing this because depending on how many simple statements we have in an argument, right, depending on how many variables, the truth table could become rather large and it just gets out of control and it's too much work. So that's pretty much what I have here in this first paragraph, that as the number of variables involved in an argument increases, the truth tables used for testing validity become unwieldy. So another technique called the true-false method provides a more expedient or quicker means of determining the validity of an argument. So this is how we're going to approach this method. We're going to assume that all the premises are true, and we're going to try to arrive at the truth value of the conclusion. If the true premises can possibly result in even just once a false conclusion, then the argument's invalid. But if true premises always lead to a true conclusion, then the argument will be valid. So if there's just one instance that we end up with true premises and a false conclusion, the argument is invalid. So let's do an example. And we're going to use the direct approach, no more truth tables. So let's determine if this argument is valid or invalid. And we actually did this example in the previous lecture, but we used a truth table. So I'm going to show you how we could come up with the validity of this argument, but in a much quicker fashion. And the results are going to be the same. This was valid when we did it in the previous lecture. So let me show you another way that we could come to that valid conclusion. So the first thing is, if we have an argument in words, let's change it to logic notation, right? So let's rewrite it using variables. So we will go to the game, we'll use G, or we will study S, and that's it. We just have those two variables. So let's write this as an argument using symbols. So the first premise is we will go to the game or study. So G or S. The second premise is we will not study. So not S. Therefore, so that's the conclusion. So we're going to draw our line and now state the conclusion. We will go to the game and that's G. So with this approach, we're going to assume all the premises are true. So we have two premises in this case. So we're going to assume that they're true. Based on this, let's see if we can arrive at what the truth value of the conclusion is going to be based on the fact that both premises are true. Now we want to be able to figure out what the G and S are in terms of their truth values based on the fact that these two premises are true. So if the second premise are true, that means not S is true, right? Which means that S must be false. So if S is false and it's in the statement G or S and we're assuming it's true, what's the only way an or statement could be true if one side of it's already false? That would make G true, right? G would have to be true. My conclusion is also G, right? So then this G is also true. It's the same G, right? So look what we just figured, that when both our premises are true, the conclusion has to be true as well. Therefore, our argument is valid since true premises are leading to a true conclusion. So let's look at this second example. Determine whether the argument is valid or invalid. So we have three premises in this case, which we're going to assume are all true. We're always assuming that the premises are true, because remember, to show that an argument is valid, we just have to show that whenever the premises are all true, the conclusion is also true. That would show that it's valid, right? But then if there's instances where all the premises are true, but it leads to a false conclusion, then that's our counterexample, right? Showing that the argument is invalid. So that's why we're always assuming the premises are true. So based on this, let's see if we could determine the values of P, Q, and R, right? Because those are my three variables in this case. Well, if not Q is true, then that means that Q is false. So let me do a different color here. We'll do red. So if not Q is true, then Q is false. But we have an or statement, right? The only way this or statement could be true, if one side is already false, that means that the left-hand side, not P, has to be true. So if not P is true, then that means P is false. But we have a conditional statement. The statement we're assuming is true. And the only way this conditional statement could be true if the right-hand side is false is that R would have to be false. Because otherwise, if R was true, we'd have true implies false, and that would be false, right? So R is forced to be true. I'm sorry, R is false, forced to be false, which then makes not R, which is our conclusion, true. It's forced to be true, right? If R is false. So in this case, all my premises are true, and that's going to also lead to a true conclusion. So this argument is valid. See, this is much quicker than using the truth table approach. So let's do another one where we have to first read it in words, right? And then we'll represent it using variables, and then we'll look at the validity. So we have the first one. The first premise is, if my salary increases by 5%, I will go to Rome. So let's use actually, let's use S. We'll use S for my salary increases by 5%. I will go to Rome. Let's use R. The second one says either I go to Rome, which we already have R for that, right? Or I buy a computer. So let's use C for I buy a computer. Next, we have I didn't buy a computer, so that would just be not C, right? I don't need another variable. Therefore, my salary didn't increase by 5%. And we already have S for my salary increases by 5%. So we just have three different simple statements here, right? We're going to use S, R, and C. So now let's represent this using letters. So if my salary increases by 5%, so if S, then I will go to Rome. So then R. That's my first premise, right? So here we have 1, 2, 3 premises. And then the therefore, right, that makes the conclusion. So first we have S implies R. The second premise is either I go to Rome or I buy a computer. So we have a disjunction. So we have R or C. The third premise is I didn't buy a computer. So not C. Therefore, so draw your line for your conclusion, my salary didn't increase by 5%. So not S. So let's test the validity of this statement using the direct approach, the true-false method. So let's assume all our premises are true, and let's see if that's going to also lead us to a true conclusion or a conclusion that could possibly be false. So assuming my premises are true, then not C is true, right? That third premise, not C is true. So if not C is true, then that makes C false, right? So C would be false. but it's within the statement R or C, and it's assumed to be true, right? We're assuming this premise is true. So the only way this or statement could be true if the right-hand side is false is if the left-hand side is true. So that makes R true. So then this R is also true. It's the same R, right? So we have this conditional statement that we're assuming is true. The right-hand side is true. So what does that tell us about the left-hand side S? Well, if S was true, true implies true is true. Or if S was false, false implies true is still true. So actually, S could either be true or false, and it would still make that first premise true, right? Well, if S is true, then not S, which is the conclusion, that would be false, right? So if S is true, then not S is false. And then we would have three true premises, but a false conclusion, right? And that would make the argument invalid. But if S was false, then not S would be true. And I would have three true premises and a true conclusion. But the fact, hold on, I'm just trying to draw this negation. There we go. But the fact that there is one case where we would get a false conclusion, right? When the premises are true, that makes the argument invalid. And that would happen when this is the case that I just circled in red. So this argument is invalid, and we want to produce a counterexample chart. So the counterexample would be, so we have these three variables, right? We have C, R, and S. So what would their truth values be? That's going to lead us to a false conclusion, right? When our premises are true. So C is false, right? So I'm just going back up here. You see how C is false. We already determined that. We determined that R is true. But S, we said, would have to be true in order for the conclusion not S to be false, right? And this would lead to the counterexample. So C is false, R is true, S is true. So that would be the instance when all our premises would be true, but my conclusion would be false. So let's practice a few more. So this last page is just, continuing to determine if the given argument is valid or invalid and producing a counterexample. And we're still going to use the direct approach, the true-false method. So very similar to what we were doing up here. So let's look at this example. So again, we're assuming the premises are true. So if my three premises are true, that means not W is true, which then makes W false. And we have an or statement, but the or statement is assumed to be true, which means the left-hand side, not D, would have to be true. And then not D over here would have to be true. And we have true implies, and I don't know what G or N are yet, but this is the right-hand side of a conditional, right? But we want the conditional statement to be true. So this or statement can't be false because true implies false is false. So this statement, G or N, has to be true. Now, I don't know what G or N is, but let's think about this. In order for an or statement to be true, one side has to at least be true, right? So what if N was true? If N was true, then the conclusion would be true, right? But, and we'd have three true premises and then a true conclusion. But what if N was false? if N was false, right, then G would have to be true, because true or false is the only way we're getting a true or statement. But since we're assuming for this instance N is false, then the conclusion would be false. And then that would lead us to say that this argument's invalid, right? Because we would have 3 true premises, but a false conclusion. So this argument is invalid. And the counterexample would be when, so let's list, we have D, G, N, and W. So not D, we're assuming is true, right? So D would be false. We said that G would have to be true. N would have to be false. And we figured W is false, right? So this is the instance when my conclusion would be false, but my premises would be true. So that's my counterexample. So let's look at this next example to the right. We have 2 premises. Let's assume they're true. So under that assumption, then K is true, right? So then not K over here is going to be false. But we have an implication, right? We have a conditional statement. So something to a false has to be true. Well, the left-hand side can't be true because true to a false is false. So it has to be false. And it's an or statement. And the only way an or statement is false is if both sides are false. So S would have to be false and D would have to be false. And if S is false, then not S would be true. And then that would force the conclusion to be true as well when the premises are true. So since this would always result in a true conclusion, right, when our premises are true, this would be a valid argument. Let's look at the next one. We have 2 premises, so we're going to assume they're both true. I'm going to start with the second one because I could figure out if I have an end statement and it's true. The only way an end statement could be true is if both the left and the right hand side are true, right? A true and a true is true. So that means C is true and not A is true, which then makes A false. And we already said C is true, right? So this C over here is true. And we have a conditional statement that has to be true. So let's think about this. In order for this conditional statement to be true and the left-hand side is false, the right-hand side could also be false because a false implies false is true, but it could also be true because false implies true is also true. But the fact that we have an or statement right here and C is true, whenever we have part of an or statement, the left or the right-hand side, and it's true, it makes the whole statement true, right? So this or statement is true because the right-hand side is true. So we have false to a true, which makes this premise, are assumed to be true. But we still don't have a value on B, right? But B could be either or because in an or statement, right, as long as one side is true, the whole statement is true. It doesn't matter if it's true or false. So if B were true, then my conclusion would be true. But what if B was false? Then my conclusion would be false. And that would lead to an invalid argument, right? And that would be a counterexample. So this is an invalid argument. And my premises are true, but my conclusion is false, when A is false, B is false, and C is true. So we have two more. Let's look at this one. So we have three premises. We're assuming they are all true. And now we want to start figuring out the truth values of the different variables, right? And I'm going to start with not Q because I know it's true, right? So if not Q is true, then Q is false. So that makes Q false. And we have a biconditional. And the only way a biconditional can be true, right? Because we want that whole premise to be true, is if both sides are true or both sides are false. But the right-hand side is already false. So in order for this statement to be true, the left-hand side would also have to be false. And that's a conditional. And the only way a conditional could be false is if the left-hand side is true and the right-hand side is false. So that would make M true and N false. And not N then would be true. So not N would be true. And we're in an or statement, right? It's not N or W. So the fact that the left-hand side is true, it makes the whole disjunction true. And we have a conditional, true to something has to be true. Well, true to false is false. So it has to be true to true. So that makes S true in order to keep this premise true. And then S in the conclusion is true. We don't know what A is. However, it doesn't matter because as long as the right-hand side is true in a conditional, it doesn't matter what the left-hand side is. The statement's always going to be true. So in this case, whenever we have three true premises, my conclusion is going to be true also, regardless. So this is a valid argument. And we'll do one more example. And then you guys should be ready to practice these on your own for the homework. So this one here has four premises. We're going to assume that they're all true. So let's try to figure out what the values of P, R, S, W, and C would have to be. So I'm going to start with this and statement, this conjunction, because the only way a conjunction can be true is if both sides of the conjunction are true, right? So that would mean that not R is true and S is true. So then that would make R false and not S would be false. Now let's think about what we have going on here. So we have a conditional in that first premise, but the right-hand side of it, R, is false. But we need this premise to be true. So the conditional has to be true. So that makes the left-hand side has to be false. Because a false implies false is true. If the left-hand side was true, true implies false is false, which doesn't work, right? So now we need this or statement to be false, right? The statement that I circled here, the left-hand side of this conditional. We need the whole thing to be false, but it's being negated. So whatever this or statement is has to be true, right? Because with the negation in front of it, it makes it false. Now, if not S, the right-hand side of the or statement is false, the only way that this or statement could be true is if P was true. So true or false is true, but we're negating a true, making this left-hand side false. So we said, okay, P has to be true, which means this P down here is true. And we have a conditional statement that we're assuming is true, so W has to be true. Otherwise, we would have true to false, which is false. So W is true. Now let's talk about C. C now could be either true or false, right? Because a true to a true is true, or a false to a true is true. So C really could be either or, but when C is false, the conclusion would be false. And that would show that this argument is invalid, right? And we would have a counterexample. So my counterexample, so we have C, P, R, S, and W would be, we just said when C is false, we determined P is true, R is false, we determined S is true, and W is true. So this would be our counterexample that shows that we do have a case where all our premises are true, but my conclusion's false. So that wraps up this lecture on section 2.2. And you're going to have homework to practice this approach using the direct approach and assuming the premises are true and seeing, how it rolls out in terms of if your conclusion has that possibility of being false, then we know the argument's invalid and you guys could show your counterexample.